here's what it actually looks like. And again, in this case, you can see 3 files, but in this case, it's not the actual file content, it's only the metadata. And here we've got our progress bar going much faster, much less elapsed time. And then if and only if you need the actual individual file content, we will deliver it on demand. In this case, someone chose to edit the .wav file, and then somebody chose to open the .mov file or the movie file. But in this case, nobody actually requested, or the individual user didn't do an operation locally that required them to have the JPEG image. So in this case, it doesn't actually get fully transferred down to the client because the client doesn't need it. The client is fine with just the metadata. Now let's jump to the sequence diagram again. Second bubble from the right, the second column is the P4 command line client again. It is doing exactly what it did before, and it's requesting sync operation. This time the server is only replying back with metadata. So file A, B, and C is only 1K respectively in size. And now the client P4 is passing this on to this new P4 VFS agent. This agent gets installed locally. I'll show this in the demo here in a couple minutes. And what that agent is doing is acting as a pass-through back to the operating system. So it's simply saying, all right, the client is passing me back some metadata. I am passing this on to the file system. In this case, the entire operation completes, and there's only a total of 3K being transferred instead of that 135 megs that we saw before. Now, the interesting part is when we actually need to hydrate or download the actual file content. So in this case, you've got some app. This app could just be Windows Explorer. It could be P4. It could be P4V. Again, it could be a custom client. It doesn't matter what it is. Somebody is doing an operation that requires that local file content to be delivered. So in this case, it's being passed through the file system, which knows it only has a placeholder or a shell, which is then telling the agent, hey, there's work to do here. You need to download the actual file content. And so then the service itself is requesting back to the server that it needs the file content. And it's actually kicking off a pre-for print command in this example. So again, the initial sync used the sync command. The actual hydration of individual content uses P4 print. In this case, the server says, all right, I'm going to send you the file content back. And in this case, it's file A, which again was only 10 megs on our initial example. So that 10 megs is passed back through the agent to the operating system and delivered back to the app. So this is how, under the covers, this is all working when an actual file needs to be hydrated or fully realized, downloaded, whatever you want to say for the term, to an application, which is local on the client. So let's talk about the solution itself. When we went to go after this implementation, we looked at multiple different options in terms of technology, how to actually implement this. The first place we looked was Fuse. The appealing part of Fuse is it's cross-platform. So we only have to build it once on the client side, and it's going to work across all 3 major platforms. That's very appealing from an effort perspective and a long-term maintainability perspective. What we found out, it is kind of mostly cross-platform, not 100%. There are some tweaks that we need to make based on the platform. We also found out it's not as performant as we wanted it to be. We realized that hydrated files need to be stored outside the workspace directory, which is just an annoyance. And any sort of UI for things like progress, when you're actually realizing or downloading files, would have had to be custom built by us. So that was the first option we looked at. Again, not knocking anybody that goes the Fuse route. It's one that we evaluated, but ultimately decided not to go with. So the second thing we looked at was custom NTFS reparse point mini filters. Again, this solution, unlike Fuse, is specific to Windows. We found that it was more performant than Fuse. That was good. The cons from our perspective is we had to get into the driver signing business. We had to get into redistributing certifications. There, again, was no integrated UI. And what we weren't sure about is if we put all this effort into this, we get it up and running, we get it working, how long is it going to be supported by Microsoft itself? Obviously, we don't want to put all of our effort into something that all of a sudden Microsoft pulls the covers out from under us and we're left in a state where our solution no longer works. Also, we just felt like with driver signing in particular, this was just putting too much onus on the end user in terms of getting this working. And the less friction we have in terms of the install and operation process, the better. So the next thing we looked at was the projected file system. Again, when I talked about the history of sync in an earlier slide, we talked about how we ourselves were in the audience for when Bungie gave a talk at GDC, and they use the projected file system, or ProjFS as it's known. Again, this is a Windows specific implementation. We found it's very much performant. We also like the fact that it offered flexibility in terms of what the server thought the file size was on the client. So things like line ending, Unicode, byte order markers, all these things could kind of be ignored and weren't a problem. So if when we went to say, go hydrate that file, we thought it was X, but when the file was actually hydrated, it was X plus 5, it didn't matter. It would still hydrate successfully. The cons in our perspective, and again, it's just subjective whether it's a con or not. From our perspective, we thought it was, and that is, again, was no integrated UI, so we'd had to build that component ourselves. We were, again, kind of unsure about the long-term support from Microsoft, because when we did our internal POC, it was a lot of hacking around and figuring stuff out. Not a lot of documentation on how to do it the right way, or even give you hints at how to do it. And then there was a specific thing we had to do to just enable ProjFS itself inside of Windows, which again, just goes back to that kind of friction in terms of an end user installing this and trying to get it up and running. So our last thing that we evaluated was called the Cloud Files Provider, and this is also built into Windows. When we tested this out, we found it was performant. We feel like out of anything that we could have chosen that was Windows specific, this seemed to be the most supported option. There is an actual UI that's integrated into CFP, and there are no extra feature enablement or drivers to worry about. The con is, while there is an integrated UI, we have very little control of what that UI does. And so again, every solution that we evaluated here had its own list of pros and cons. There's no reason why we couldn't have gone with any of these, but at the end of the day, what was most important to us in terms of our criteria led us to the CFP solution. And so what we're going to show today is built off of the Cloud Files Provider, which is again built directly into Windows.